Hey guys, welcome to Fundamental Theorem of Calculus. In this lesson, we're going to be extending our knowledge of Fundamental Theorem of Calculus. We know that FTC is area, implies area. If you find the area under the curve, you're using the Fundamental Theorem of Calculus to do so. But we're going to go ahead and apply this to solve for functions at a certain value. So, given the derivative, 3x squared plus 4x minus 5, with initial condition 2 comma negative 1, we're going to find y of 3. So we're not just going to be able to solve the differential. Once we solve the differential, we're going to figure out what is the function at 3. So your method number 1 would be to do so, to solve the differential like the way you guys have known how to do it. dy over dx is equal to 3x squared plus 4x minus 5. And I taught you guys that remove dx from dy, so that you get dy is equal to 3x squared plus 4x minus 5 dx. And if you want a y from a dy, you have to integrate. So this becomes y is equal to x cubed plus 2x squared minus 5x plus c, since we're integrating indefinitely. And then how do you solve for c? You're going to use your initial condition 2 comma negative 1. Negative 1 is y, 2 is x, okay, so 2 cubed is 8 plus 2 times 2 squared, which is the same thing as 2 cubed is another 8 minus 10 plus c is equal to negative 1. 18, no, that's 16, take away 10 is 6. And then when you subtract 6 to both sides, you get c is equal to negative 7. So that my particular solution is y is equal to x cubed plus 2x squared minus 5x minus 7. That is my c. And I'm not done yet, because it says here find y of 3. In other words, find y when x equals 3. So y is equal to, so this would be your particular solution. This is what we were doing before, and now we want to use the solution to find values of the solution. So let's go ahead and plug into 3. 3 cubed plus 2 times 3 squared minus 5 times 3 minus 7. And that gives us 27 plus 2 times 9 is 18 minus 15 minus 7. This is 45. This is 22. So my answer is 23. That is method number 1. Now, method number 2 is just a slight variation of method number 1, but it can actually make things a little bit more simpler, a little more organized. So let's review what the fundamental theorem of calculus is. The fundamental theorem of calculus is that when you take the definite integral of a function, you get the antiderivative, you plug in b, minus the antiderivative when you plug in a. So we're going to use this theorem to help us solve y of 3. Now, notice, they gave us, here, let me just clean this up a little bit. This is the information you need to use. What is the lower x value? 2. The higher x value is 3. So this is going to be my a, and this is going to be my b. I have to use what's given to me. So I'm gonna rewrite this as the integral from 2 to 3 of the derivative, which is the same thing as f prime, (3) x squared plus 4x minus 5 dx is equal to, and then when I use the fundamental theorem of calculus, I'm supposed to get f of 3 because that is my upper bound, 3 minus f of 2. Okay, so let me erase this. There it is. Okay, now what in the problem given to me, what do I know is true? I know that when x equals 2, y is negative 1. So when x is equal to 2, y is negative 1. So I know that this is a negative 1, which will turn into a positive. But before I do that, what am I solving for? If you look at the problem above, I want to find the value at 3. I want to solve for f of 3. So how do I get rid of a minus minus 1? I'm going to add a negative 1 to both sides. To both sides, add a negative 1 so that I get the integral from 2 to 3 of 3x squared plus 4x minus 5 dx, and then minus 1. All this should equal to my answer above, f of 3. And then all I got to do is compute the integral, the definite integral. What is the integral of 3x squared? That is x cubed. What is the integral of 4x? 2x squared, 5x. But now I'm doing the definite integral, so I'm going to plug in 2 and 3. And then after I plug in 2 and 3 and I find those numbers, I take 1 away and I should get the number I got above. So let's go ahead and do so. When I plug in 3, I get 3 cubed plus 2 times 3 squared minus 5 times 3 minus 2 cubed plus 2 times 2 squared minus 5 times 2. And then minus the 1. 27 plus 18 minus 15. And then let me distribute this already. Minus 8 plus 10. And then last but not least, minus 1. So let's go ahead and add up all these numbers. 27 plus 18 is 45. Take away 15. This is 45. Take away 15 is 30. Minus negative 16 plus 10. Negative 16 plus 10 is a negative 6. Minus 1 is a negative 7. So it's 30 take away 7, which is 23. And there it is. 23, 23. It's just another way of solving for differentials and also finding a solution to the differential, a point on the differential. So that is method number 2. Now, sometimes you're going to come across a problem where there is no antiderivative. So for example, how would you do the antiderivative of this problem? Let me read the problem. So f prime is equal to sine x squared, and f of 1, which is the same thing as 1 comma negative 5, is on the point of f, not f prime. And it's the point of f, and you want to find for f of 2. Well, you would probably want to integrate sine x squared and try to solve the differential by finding the c and all that stuff, but you can't integrate sine x squared, because if you let u equals x squared, you get du is equal to 2x dx, and you don't have an x, you only have the dx. And you can't let u equal sine x squared either, because then you would get something cosine and you'd have nothing cosine. So in this problem, you have no choice but to use method number 2. Method number 2 says you have to use what's given. This is going to be your A, this is going to be your B. The reason why it shows that to be A is because 1 is smaller than 2, and we usually write the integrals with lower bound and upper bound. So the integral of the derivative, which is sine x squared dx, is equal to we know that if we apply the fundamental theorem of calculus, it should be something f2 and some function with 1 plugged in. That's when we apply that is the f of b minus the f of a. And what are we trying to solve for? We're trying to solve for f of 2. So we add f of 1 to both sides. Sine x squared dx plus f of 1 on the outside is equal to f of 2. What is f of 1? F of 1 is negative 5. So f of 2 is the integral from 1 to 2 sine x squared dx minus the 5, because that's the f of 1. And you have no choice but to use a graphing calculator to find the integral for this problem. So let me pull out my calculator. Okay, so using the calculator, give me a quick second. Using the calculator, I had to find the antiderivative. I had to find the integral. This is not computable by hand. And when you take a Calculus 2 course or a higher calculus course, you'll be able to find other methods of integrating this, but this is not integral by hand, so you would have to use a calculator, and you get 4.945 take away 5. So take away 5 and your answer should be a negative 4.505. And that would be your answer for this antiderivative here. Now, what if you had been given f of 2 and you were asked to find f of 1? So I'm going to go ahead and copy this equation up here. So the question was, what if I was given f of 2 and then I wanted to find f of 1? What happened? Okay, let me just rewrite this. This didn't work out. Sine x squared dx is equal to f of 2 minus f of 1. So if I wanted to solve for f of 1, so let's say I already have f of 2. Let's say I already know what that is, and I wanted to find f of 1. Then I would solve for f of 1 by adding both sides of f of 1 and subtracting the integral to both sides, so that I can get f of 1 is equal to f of 2 minus the integral of 1 to 2 of sine x squared dx. And that's how you would find f of 1. So it's the same process as finding f of 2, except you have to put a little bit more arithmetic into it, because now you have a negative f of 1 and you're solving for f of 1. So let's go to, in the next video I'll show you guys the next page of this lesson here.